Now let's see another code example of closures. Imagine we have this function to order some coffee in a coffee shop. Now Kate is having a latte, while James prefers an espresso. Here you can see how we have a parent function and a child function inside of it, and how both functions are using the same variables. Nothing weird so far, because the child function has full access to the variables inside its parent function. We'll see why in a minute. Now, if we convert this child function in the result of the parent function, we can store it inside a variable outside of the scope where it belongs, so the parent function scope, and then call it from outside. This way, we will be using the values of the parent function inside of the child function, but the thing is that this parent function, by that time, will have already been removed from the execution stack, which is a place in memory where all the functions of a program are executed. And with this deletion, all its variables inside will be also gone, once the function is already executed. So the question is, how is the JavaScript engine able to use some values after they've been removed from the stack? Well, here's where closures come into play. In fact, they are removed from the stack, but they're still there somewhere else, in some other section of the memory. So in this example, it's like if they ask for coffee again to some other waiter, and they say, "Can we have the same again, please?" This waiter doesn't know what they're having, but he will probably go and check what that table ordered the first time, in that table's order. So the JavaScript engine does a bit the same, and writes down that information inside of an object which is stored in the heap memory away from the call stack. Now, to understand how this works and see how everything fits together, we need to talk about several concepts that are part of closures, but we'll see them in the following videos. I'll see you in just a minute.